Okay, in part two, we're going to look at some measures of position. So in the first part, we looked at some measures that describe the data set, the center, the spread, the mean, standard deviation, things like that. So now we're going to do measures of position. So what a measure of position is going to do is it's going to see how one data point actually relates to the rest of the data set. So instead of looking at the group as a whole, we're going to look at one data set individually. So one of the most important things we'll use for a measure of position is what's called a percentile. Now a percentile is going to be the percent of data below a given data value. So it's what percent of the data is below a given value. Now this could be a large data set, it could be a small data set, but it's the percent that is strictly below a given data value. So if I have maybe a couple pieces of data, 3, 5, 6, 8, if I look at this data point is in the 50th percentile because there are 2 data points below it out of the 4 data pieces there are. So this one is in the 50th percentile. The 8 would be in the 75th percentile because there's only 3 out of the 4 below it. So you only do the ones below it, so you can never really have the 100th percentile because you can never be below yourself as a data point. So a couple special percentiles we use are what are called quartiles. So quartiles are essentially percentiles that are going to break the data set into 4 parts. So the quartiles are going to break the data into 4 parts. So we will have our lowest 25%, our second 25%, our third 25%, and then our top 25%. So if you think of a continuum, we have our minimum value down here, we have our maximum value down here, and then we're going to split this with 3 values to have our bottom 25, second 25, third 25, and top 25. And then we just give names to these things. So the middle one you should know, because it's the value that's going to cut the middle 50%, that is the median. We've talked about that before. And so then we have a couple different things that are going to cut the bottom 25 and the top 25, and we call those the first and the third quartiles. The first quartile is the value that the lowest 25% of the data will fall below. It's the median of the lower 50%. So if you have this bottom 50%, the middle of that is going to be Q1. And then similarly, you will have a value that will cut off the top 25%. We call that the third quartile, and that's called Q3. But again, it's just found by finding the middle of the top 20 or top 50 and bottom 50. So the last thing we'll do with the quartiles, and this is a very, very important part of spread in a data set, is we use the interquartile range. So the interquartile range we call is the range of the middle 50%. So what we want to do is we want to find out how far this middle 50% is spread out. If your middle 50 is really compact and not very far spread out, that means one thing. If you have a larger middle 50, that means something else. So since it's just that distance, the IQR can be found with a pretty simple formula. It's just Q3 minus Q1. So once you find those quartiles, you just subtract them. So let's look at an example here where we're going to try to find the IQR for the following data set. Now, if I'm going to find the IQR, I have to find the median and kind of break it into the different parts. But the first thing I see is I need to put this data in order because it is not in order. So it looks like 5 is my smallest one. Then if I look at the ones that are in the teens, I got 10, 10, 15, 15, 15, 15. So I have a 10, and then another 10, and it looks like I have 4 15s. So So I'm just, again, putting it in order. Now for 20s, I have a 20 here, 20 here, a 20 here, and a 25 here. So it looks like I have 3 20s and a 25. So go and cross all those out. For 30s, I have a 30 and a 30, so 2 30s. And then we have a 40 and a 40 there and a 45 there. So we'll have a couple of those, so a 40 and a 40 and a 45. And then we have 2 60s. $65, and then we have that big 85. So there's my data points. So when we're trying to find the interquartile range and the quartiles, the first thing we're going to do is find the median. So first what I'll do is I'll count how many data points there are. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 data pieces. So the median, the middle, would be in between 10 each. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this is my 10th data piece here, and this is my 11th data piece here. So our median is going to be in the middle. So in between 20 and 25 is going to be 22.5, so that's the median. So now for quartile 1, I'm going to find the middle of these bottom 10 data pieces. Well, since there's 10, the middle of that is going to be 5 on each side, so we'll go 1, 2, 3, 4, 5. So the middle here is going to be my Q1. Well, it's in the middle of 15 and 15, so it's 15. And up here, 1, 2, 3, 4, 5. Q3 is going to be there. And this is only in between because they're even. Remember, if it's an odd number of data pieces, it would just be the middle number. So Q3 is in between those two, so that's 42.5. So putting them in order was definitely the most work there, and then you just try to line them up and find where it goes. You can also, if you recall from our graphing calculator thing we did in the first part, where we found the standard deviation and the mean and all those kind of things, at the very bottom of that same list, under that one variable stats, you had Q1 and Q3, so you can find them in the graphing calculator as well. So then if I want to find my IQR, I'll just subtract, so I'll do 42.5 minus 15. 42 minus 15 is going to be 27.5. So that is going to be my IQR. And so what that number represents is that is going to be the spread between the lowest and the upper part of the middle 50%. The last thing that we're going to look at is we're going to look at, remember, outliers. So outliers, if you recall, outliers are going to be the values that are far away from the middle. And we kind of did it very informally earlier. We said, well, if it's pretty far away from the group, then we can say it's an outlier. But we want to actually put in a formal rule on this to figure out when something is an outlier. So an outlier, we're going to say this. We're going to say a data point is an outlier if that data point is less than Q1 minus 1.5 times the IQR. This is why this is called the 1.5 IQR rule. So if you take 1.5 times your IQR and you subtract that from Q1, if you have a data point less than that, then we consider it an outlier. We also say, in general, if it is greater than Q3 plus 1.5 times the IQR, we would consider it an outlier. So what you'll notice for both of these, what I need is I need the quartiles and the outliers to determine if it is an outlier. So we'll look at an example of this where we have a data set where we have the fat contents in grams for one serving of 14 brands of cereal bars given by the following. So again, we have some data. The first thing I'm going to have to do is put it in order. All right, so here's our data listed in order. So we have 14, so if I'm finding the median, there should be 7 on each side. 1, 2, 3, 4, 5, 6, 7. So in between those two is going to be my median. So my median is going to be 8. Not that I need that, but it helps me to find the quartiles. And so now if I do, since there's 7 on each side, the middle one is going to be quartile 1 here. And the middle one down here is going to be quartile 3 here. So my IQR is going to be 14 minus 6.5, which is going to be 7.5. So now remember, we're trying to determine if there are outliers in this set. So what I'm going to do is I'm going to have to use the IQR rule. So I'm going to calculate when is it less than Q1 minus 1.5 IQR. So Q1 is 6.5 minus 1.5 times the IQR, which is 7.5. Or a value can be greater than Q3, which is 14, plus 1.5 times the IQR. So these are just mathematical formulas that you can plug in and figure out what you get. So when I put this in the calculator, I'm going to get less than negative 4.75 or greater than 25.25. So now I look at my data set and I think, all right, are any of the values less than negative 4.75? No, they're not. Are any of them greater than 25.25? No, they're not. So in this data set, I would say there are no outliers. So now we have kind of a more steadfast rule to go back to and actually plug in numbers and see if our values are too big and too small to be considered outliers. So the last thing we want to look at is what's called a box plot. And a box plot is a graph of what we call the 5-number summary. So a 5-number summary is the group of statistics that we use a lot to look at a set of data. And they are the median and the quartiles and the max and the min. And what we usually do to use those is we can use a box plot to graph it. So a box plot is going to be a graph of the 5-number summary. Pretty easy to form. So we'll practice the one above. You can do some box plots on the TI calculator. It's not something we're really going to focus on. They're pretty tough to do in Google Sheets and things like that. So we mostly will make these in this course by hand because most of our studies and things will not need technology box plots, but you can do them in the calculator if it's something you want to look at. So I'm going to try to graph the 5-number summary, which remember is the min, the max, Q1, Q3, and the median. And the goal of this is, a box plot is trying to look at how spread out is the whole data set and how spread out is the middle 50%. So if I look at a box plot, the first thing I'm going to do is I'm going to make a line, an axis. So I'm just going to make an axis here. And then I'm going to scale it. So since I'm going to do the one from above where I'm talking about the fat content, the minimum was 2 and the maximum was 18.9. So maybe I just go by 2s. Now you always want to make sure you scale your axis first. You don't want to start writing it and scale it later. So make sure you have it scaled before you put it. It's only a one-dimensional thing, so you only need a 1-number line. So there is my scale. So for the 3 middle ones that represent the middle 50%, what we're going to do is we're going to put lines. So Q1 from above, remember, was 6.5, so I'm going to put a line above it. Somewhere there. There's 6.5. And then the median is at 8. I'm going to put another line there. And then at the third quartile, which is 14, I'm going to put another line there. So it looks something like this. So right away you can see that it's much more stretched to the right in that middle 50%. So this middle box is the middle 50%. You can see the middle of that middle 50% with the median. Then all we simply do is we will put a dot down here at the minimum and connect it like this. And then we'll put a dot at 18.9 for the max, and we'll put a line like this. So if I look at this box plot, it kind of tells me how spread out my data is. It looks like it's a little more spread out over on this side than the other side, but you can definitely see that where the spread really kind of comes in more. These are pretty popular to see in a lot of research, so it's good to know what this actually represents, the middle and then kind of the extreme quartiles. So the final page here is something we're actually going to look at in class. So if you want to try it now, that's great. You can use your calculator. You can do it by hand. But this is a data set, and we're going to try to find all these different things. So nothing you have to worry about now, but I just want to mention that this is something we're going to do, but we're going to do it together in class. If you do have questions about the other stuff, obviously, please do let me know.